So it's the same thing over and over again. Anyways, you have this. The first option is कि elements B, J, and R are in group 18 of the periodic table. तो B किधर है? B is this one. ठीक है. Where is J? J is over here, and this is R. So they're definitely in group 18 of the periodic table. क्योंकि across the period, the ionization energies keeps on increasing across the period, और सबसे highest जो होती है वो noble gases की होती है, ठीक है, at the end. So that is true. The next one is atoms of elements D and L contain two electrons in the outer shell electrons. So D outer shell electrons with two electrons. That means it's in group two. So this is group one, and this one is group one. So the next one is going to be group. The next one is going to be group two. So D, that's definitely group two, and L, that's also group two. So that statement is also correct. The third one is atoms of elements G and O have half-filled p subshell. अब half-filled p subshell किसका होता था? Which element had an electronic configuration of S2 and P3? ठीक है, remember group 1 was S1, group 2 was S2, group 3 was S2P1, S2P2, S2P3. तो group 5 जो होता था ना, their electronic configuration, ठीक है, always remember that group 5 had an electronic configuration of S2P3. So which elements? G, that's definitely group 5, and O, that's also group 5. ठीक है, वो करके देख लो. This is 1, this is 2, this is 3, this is 4, and this is 5. Group 1, 2, 3, 4, and 5. So they are in group 5. As the next question, elements X and Y are in the same group of the periodic table. They are in the same group. The table shows the first 6 ionization energies of elements X and Y. तो पहले तो ये देखना है कि which group do they belong to? Successive, removing the first electron, easy. Second is easy. Third is easy. Fourth is easy. Fifth is also kind of easy. Sixth पे जाके एकदम से there is this huge jump. और ये दूसरे element का भी exactly same है कि between the fifth and the sixth, removing the outer electrons was kind of easy. फिर एकदम से inner shell आ जाता है. So that means it has 5 electrons in the outer shell. 5 electrons which are in the valence shell. So they're definitely in group 5. So let's open the periodic table and find where is group 5. So this is group 15. So it's antimony and Sp. They are given As and Sp. Okay, so As is given and Sb is given. Okay, that's group 5. So how do you figure out the answer to ये tellurium and Se जो है वो तो निकल गया. ठीक है, it's either A or, so the answer is going to be antimony or As or Sp. So how do you figure out which one is As and which one is Sp? So the next part is कि मतलब we figured this out कि group 5 में तो वो है. ठीक है, मेरा ये clear है?
जी
अच्छा, अब what we need to figure out is we learned that ionization energies decrease down the group. ठीक है, बड़ा atom है तो they decrease down the group. It becomes easier to remove electrons. So Sp के लिए it's going to be easier to remove electrons. As के लिए it's going to be kind of more difficult to remove electrons. So Y के लिए, if you look at the ionization energies, it's easier to remove electrons. No, not easy. It's actually difficult. Y के लिए ना it's actually difficult. X के लिए it's easy. X की ionization energies की values देखो. ठीक है, the values are lesser. Smaller values है. तो इसका मतलब है it must be X must be this As. ठीक है, easy to remove electrons. नहीं, not As, फिर गलत कर दिया. Sp would be X and As would be Y. ठीक है, down the group it becomes easier to remove electrons. So Sp would be X, easy to remove electrons, values कम है. और वो दूसरा more difficult to remove electrons. That would be why. That would be why. This one would be why. So which one is the correct answer? So A is going to be the correct answer for this question. ठीक है? Rida, Bazga, is this clear?
Yes, sir.
Then the next question. So the next question is you're given. Did we do this question already? One second. I think it's the same question in 17, 1, 3 getting. No, no. This is a different question. So the question again, it's kind of tricky. It's a different question. What he's saying is you have to plot the first ionization energy of NaMgAl and Si. Okay, so it's if you they're in the same period. So it's going to be if I write across the period, the graph is going to look like this. Na would be the first one, then it's going to be Mg, then it's going to be after that it's going to be Al. There's going to be a dip at Al, and then there's going to be Si. Now, who has the lowest ionization energy? So it's going to be Na. So it's going to be Na. Then the second lowest is going to be aluminium. Then there's going to be Mg, and then there's going to be Si. So that's how the values are going to be arranged. Na is the lowest because at aluminium there's a dip. The second lowest would be aluminium, then Mg, and then Si. So NaAl, Si, and Mg. NaAl. So the order or the sequence of the ionization energy would be Ni, NaAl, Si, no Mg, and then Si. So Mg and then Si. So if you ignore the vertical axis and you just focus on the horizontal axis, you would notice that this graph is arranged correctly. If you just focus on this axis over here, this part, the order or the sequence is correct. There's Na, then Al. Let me mark the values. So NaAl, Mg, and Si. So that part is marked correctly. And even for this graph as well, it's NaAl, Mg, and Si. So that part is also, these two are incorrect because the sequence on the horizontal axis is Na, Mg, Al, Si. So that's wrong. This is also Na, Mg, Al, and Si. So that's wrong. So these two are definitely incorrect. Now, what about electronegativity? What we learned about electronegativity was that if you, TK must have, uh, I must have written this somewhere. No, actually, so what is meant by electronegativity is it's a tendency for an atom. We must have done it somewhere. You can't find it. I mean, we did it kind of here. So I'm just going to quote or redo this over here. That if you have a periodic table, electronegativity is the tendency for an atom to attract a shared pair of electrons. Or so when you move to the right of the periodic table, it becomes the atoms become more electronegative because they have more protons and they have the same number of shells, and the atom size is smaller as well because of more protons, the electrons are more strongly or tightly held together. So they're more electronegative. They have a higher tendency to gain electrons, and the atoms to the top, like smaller atoms which have less shielding and have the nucleuses exposed, they also are more electronegative because they like to gain electrons. Anyways, So you have Na, that's group 1, then you have Mg, that's group 2, then Al and Si. So that is going to be the sequence of electronegativity. That Si would be the most electronegative, and Na would be the least electronegative. Na actually likes to lose electrons, so it's going to be the least electronegative. So if I go back and now focus on the vertical axis, so it's going to be Na. Okay, so let me mark the sequence now on the vertical axis. It's going to be Na followed by Mg, then it should be Al, and then it should be Si. So this, on both axes, the sequence is marked correctly. Over here, it's definitely incorrect because Na is being shown as the most electronegative one, so that's incorrect. So B is going to be your answer. Okay. Heba, Rida, is this clear? Bazga, Minahil, is this clear?
Yes, sir.
So next one. Now, the question states consecutive elements X, Y, and Z are in period 3 of the periodic table. So they're consecutive and they're period 3. So it's again across the period. Now, element Y has the highest first ionization energy and the lower. Now, Y is the middle one. So they are consecutive proton numbers. The elements are adjacent to each other, and the middle one has the highest first ionization energy. Okay, so let's have a look. This is across the period. So the middle one has the highest ionization energy. So it's either going to be so it's either going to be this one in group 2, or it's going to be this one. Okay, because if it's consecutive proton numbers, so if it's consecutive proton numbers, there's going to be X, then Y, and then there's going to be Z. So if it's consecutive proton numbers, the middle one has the highest ionization energy. Same over here as well. This is going to be X, this is going to be Y, and this is going to be Z. So you have two options. And he's stating clearly that element Y, the middle one, is supposed to have the highest first ionization energy. So these options are correct. I mean, it's either going to be the middle one is either going to be group 2, or the middle one is going to be group 5. So it's either so magnesium is fine, or you could have phosphorus. Okay, so these two options, not the other two options. Yeah, the clear. I mean, is this clear? Paza clear?
Yes.
Acha,
Yes.
so you have A or you have D. Now the other option is that element Y should have the lowest melting point as well. Now you obviously now element Y should have this lowest melting point. This thing you're not sure, you haven't studied this, but I'm going to sketch. TK period 3 is a separate topic, so I'm going to sketch a graph. TK, so you can understand the answer. It's NAMGALSI. P S, what's SI? Then 5, then S, then Cl, and then argon. So the graph sketch of melting points is like this: that the first three are metals, so the melting points are kind of high. Na isn't really high because Na is a group 1 metal. Silicon is a giant covalent structure, so like diamond, its melting point is really high. Then phosphorus is a simple covalent molecule. Sulfur is a covalent molecule as well. Cl is a covalent molecule, and this is a monoatomic gas. So this is how the sketch is. And he was saying that the middle element, so let's say this is X, Y, and Z. So he was saying that the middle element should have the lowest melting point. So phosphorus actually has the lowest melting point on this graph. So not only does it have the highest ionization energy, but it also has the lowest melting point. ठीक है, तो ये वाला part अभी we haven't done this. It's in organic chemistry. As the next part is for the sulfur, for the element sulfur, which pair of ionization energies has the highest or largest difference between them? This is sulfur, it's 2, 8 and 6. Can anyone answer? Okay, between which two ionizers?
C.
C. How many electrons does sulfur have in its outer shell? 6, right? So it's not going to be C. Removing the first electron, the second, the third, the fourth, and the fifth, and the sixth, that's easy. After the sixth, removing the seventh electron would be from an inner shell, which would be closer to the nucleus and less shielded as well. So that would kind of be very difficult. So between the sixth and the seventh. Okay, is this clear? So clear is all, yes or no? So then the next part is next question. So जल्दी से बताओ, which group is this in? Successive ionization energies are plotted. I mean, which group do you think? I mean, how many outer electrons does it have?
5.
Why 5? First electron removing the second electron. I mean, there's no big jump coming in. You get third electron, fourth electron, fifth electron, sixth electrons. ठीक है?
Oh, yes, sorry, 6. 6.
चलो ठीक है. So removing 6 electrons, एकदम से when you're trying to remove the 7th electron, that's when it almost doubles. तो इसका मतलब है 7th electron is from the inside, from an inner shell. ठीक है? ये सारे बाहर पड़े हुए हैं. ठीक है? These are on the outside. So removing 6 electrons is going to be, so it's in group 6. ठीक है? Just find which element is in group 6. कौन है group 6 में? Just one second. Group 16, TE is in group 6. So it is TE. So next one, quickly, which element is in group 4? A, B, C, and D.
C.
C is, just one second. ठीक है, C सारों का कर लेते हैं. पहले बताओ, which group is A in? Anyone?
First.
ठीक है, this is group 1. The second one, किस group में है ये? कौन सा group होगा? I mean, first two electrons.
Second group.
ठीक है, so it's in the second group, and then you have C, which is definitely in the fourth group, क्योंकि इधर तो कुछ ज़्यादा ही massive jump आ रही है कि 6,000 से it's now 37,000, so it's all of a sudden. So which group is this in? So there's a jump over here. So it's in the fifth. So next one, now he's asking, कि what is the electronic configuration of this element? And he's saying it's between lithium and neon. So how do you figure out the electronic configuration? Group number से you can figure out the electronic configuration कि किस group में है. तो पहले बताओ किस group में है ये, this element?
4th.
नहीं, not in the 4th. मतलब jump जो नहीं चाहिए, that should be a massive jump. ठीक है? क्योंकि ये
5th.
5th.
No, 6th. Sorry.
6th के अंदर है. ठीक है? It's in group 6. कि यहाँ पे there's this massive jump coming in, 13,000 to 71,000. So that's like 5 times or 6 times. ठीक है? तो यहाँ पे बस वो gradual 2,000 की change, 2,000 इधर approximately ये भी 2,000 ही है. This would be around 3,000. ठीक है? ये भी 2,000. यहाँ पे there's this huge jump. तो group 6 की electronic configuration में से कौन सी है? What is group 6? Group 1 is S1. Group 2 is S2. Group 3 is S2P1. Group 4 is S2P2, फिर S2P3, फिर S2P4. That's group 6. So it's going to be option C. अच्छा फिर ये कि हाँ ये वाला. The question is that the elements radon, francium, and radium have consecutive proton numbers in the periodic table. What is the order of their first ionization energies? The radon, francium, and radium. कहाँ पे है ये? This is radon तो इधर है noble gas है ठीक है it's over here ठीक है so this is radon then francium and then radium अब remember कि ये वो part है कि आप group के end पे पहुंचे और फिर नया period start हो रहा है so this is this part कि if I plot this over here किधर गया आपका अच्छा so if I plot it over here तो ionization energies का across the period जो graph चल रहा होता है that's like this and then you reach noble gases and after you reach noble gases एकदम से dive next period ठीक है and the same thing repeats now radon is over here radon का वो क्या था symbol क्या था that was Rn फिर radium and francium कहाँ पे आ रहा है francium is in group 1 and the last one is जो भी है radium yes. So this is how the ionization energies would be plotted. Okay, you're at the end of one period and then you start the next period. Across the period, okay, you're moving consecutive proton numbers. So उससे क्या है कि least endothermic, that's going to be francium. Francium would be the first one. And the most endothermic, that would be radon. So it's going to be option A. Okay, is this clear? Is this clear, Bazga, Minahil?
Yes.
ये हम कर चुके हैं ये मुझे जल्दी से बताओ कि which equation represents the second ionization energy of an element X? Like which one is the correct equation for the second ionization energy?
B.
ठीक है, it's going to be B. Remember कि first electron remove हो चुका होता है, so it's +1. Now you're trying to remove another electron, so it's turning into X2 plus, और वो gaseous होने चाहिए सारे के सारे. अच्छा, which factors explain why the first ionization energies of group 1 elements decrease from lithium down the group? Why do they decrease? क्या आंसर है out of the four? Okay, down the group, why do they decrease? Why is it becoming easier to remove electrons when you move down the group? कितने factors हैं? 2-3 factors हैं actually. कि electron दूर होता रहता है, so that's it's further away from the nucleus, and the other factors are कि the electron gets more shielded. The nucleus and the electron, there are lots of things in between, so it's very shielded. And the nuclear charge keeps on increasing. ये against होता था. So the correct answer to this is going to be the shielding effect of the inner shell. That's going to be one factor. ये substance वाली बात जो है spin पे repulsion ये तो इसमें आती नहीं है ठीक है वो तो उसमें आता था nuclear charge increases. This was the one that was against it ठीक है so that's the only factor. अच्छा we're going to do another thing, just a small thing. एक second, let me see the topics. नहीं किधर गए अच्छा and that is the size of the atom. ठीक है इसके ऊपर थोड़ा सा करना है और ये मैं थोड़ा सा एक्सप्लेन भी कर देता हूँ यहाँ पे ठीक है we've done a lot of ionization energy questions और ये थोड़ा सा electronegativity को मैं यहाँ पे वैसे ही एक्सप्लेन कर दूँ कि electronegativity is the tendency for an atom so it's the tendency for an atom to attract ये आएगा definition आएगी for an atom to attract a shared pair of electrons यानी bonded electrons को वो कितना strongly attract करता है जैसा Na और Cl में वो bonded electrons को Cl completely खुद ही gain कर लेता है so it's a tendency for an atom to attract shared pair of electrons. ठीक है, that's और उसकी रीजन भी पढ़ ली थी. You have क्यों होता रहता है more, you have more protons, and what else do you have? You have same shells. बाकी सब कुछ वही होता है. ठीक है, it's just that you have more protons. अच्छा, क्या next चीज what I wanted to discuss was the size of ions and atoms. ठीक है, इसका जल्दी से ग्राफ बना लेते हैं. What the एक तो पहली चीज है कि remember in your data sheet you would be given the sizes of atoms and ions across a period. That's group 1, group 2. ठीक है, इसी तरह बस पहले वो सारे लिख लेते हैं. group 3 and then you have अच्छा data sheet के अंदर ना this would be given. And this is your noble gases. खैर वो अभी 18 कहते हैं. This is 17, this is 16, 15, 14, 13. As anyways, this is so what happens to the the size of the atom. ठीक है, it's going to decrease across the period. और वो भी हम discuss कर चुके हैं. So this is going to be your atomic radius. Okay, why does it decrease? के you have the same shells. अच्छा, so you have the same shells, but you now have more protons. So group 17, like any group 17, chlorine like 17 protons, it's going to attract its electrons very, very strongly. Sodium यहाँ पे होगा, वो उसके 11 electrons होंगे, same number of shells, but it's not going to attract its electrons very strongly. तो वो थोड़ा size में बड़ा होगा. ठीक है. अच्छा, now there's one problem with this is, and that is कि ये जो last वाला है ना, इसकी this is incorrectly calculated. ठीक है, noble gases, their atomic radiuses, there's going to be an incorrect calculation for this. ठीक है, मतलब जनरल ट्रेंड है कि उसने डिक्रीज होना है अक्रॉस द पीरियड. एंड लेट मी ऑल्सो एक्सप्लेन कि डेटा बुकलेट के अंदर द एटॉमिक रेडियसेस वुड बी प्रोवाइडेड. तो हम देख लेते हैं अक्रॉस द पीरियड, उसका ट्रेंड भी देख लेते हैं. 1 सेकेंड, वेयर इज इट गिवन? ठीक है, नहीं दिस इज आयनाइजेशन एनर्जीज, पता नहीं कहीं तो थे. 1 सेकेंड. सो यू हैड बॉन्ड एनर्जीज. अच्छा, ये तो आई नहीं रहा. हाँ, here you go. अच्छा, so here you can actually see across the period. ठीक है, उसे period 3 दिया हुआ है. ठीक है, have a look at period 3. He's given you period 3. So look at the atomic radius. Sodium is the biggest one, and then you move across the period, it becomes smaller and smaller and smaller. ठीक है, तो gradual trend क्या है, यहाँ तक decrease हो रहा है. और ये last वाले को देखो, इसके सबसे argon is the biggest. ठीक है, तो why is argon coming out to be the biggest? कि उसकी आयनाइजेशन, मतलब आयनाइजेशन एनर्जी फिर से आ रहा है, वो उसका एटॉमिक रेडियस इतना बड़ा क्यों है कि जबकि प्रोटॉन्स बढ़ते जा रहे हैं. तो रिमेंबर, उसका बड़ा नहीं होता, इट्स एक्चुअली इनकरेक्टली कैलकुलेटेड. द वे एटॉमिक रेडियसेस आर कैलकुलेटेड इज कि व्हाट दे डू इज कि दे, क्योंकि एटम की जो बाउंड्री होती है ना, दैट्स वेरी इल डिफाइंड. मतलब एटम के अंदर ना वो इलेक्ट्रॉन उड़ता हुआ जा रहा है. ठीक है, डिफरेंट जगहों पे. तो मतलब एटॉमिक रेडियस आप किस तरह कैलकुलेट करोगे, क्योंकि उसकी जो आउटर बाउंड्री होगी, it's going to be very ill defined. So how do you calculate atomic radius? The way you calculate atomic radius is कि आप वो ढूंढते हो, एक एटम ढूंढते हो और फॉर जिसके अंदर वो बॉन्डिंग कर रहा हो. सो फॉर एग्जांपल यू हैव क्लोरीन, एंड दैट क्लोरीन इज उसके दो न्यूक्लियस हैं एंड दे बॉन्डेड टुगेदर. ठीक है, so there's one chlorine that's bonding to another chlorine, and they're sharing electrons, right? So what they do is कि electrons are very ill defined. आपको नहीं पता electrons exactly कहाँ पे. So how do you calculate the atomic radius? What they do is कि the nucleus is very defined. So what they do is they identify the nucleus, उसका distance measure करते हैं between the other nucleus, and they divide that distance by 2. ठीक है? हिबा, Rida, is this clear? Minahil, is this clear है?
Yes, sir.
अच्छा, so they divide the radius, divide the interatomic distance between bonded, जैसा सोडियम होगा, सोडियम metallic bonding कर रहा होगा, metallic bonding के the सोडियम के जो nuclei होंगे ना, उनके बीच में they calculate the distance and they divide by 2 and they get the radius of the atom. What's wrong with noble gas? Samajita, why can't you do this with noble gases? Anyone? कोई Minahil, any idea कि why can't you do this with noble gases? Rida, Hiba?
Because they don't bond.
ठीक है, एग्जैक्टली दे डोंट बॉन्ड. तो उसके अंदर मतलब एक नोबल गैस जो होगी वो अकेली पड़ी होगी, तो उसका उसका न्यूक्लियस का डिस्टेंस आप किसके साथ मेजर करोगे? सो दे डोंट बॉन्ड, और इवन इफ दे ट्राई टू बॉन्ड दे नॉट अट्रैक्टेड टू, सो दे डोंट बॉन्ड. ठीक है, सो इनकरेक्ट कैलकुलेशन बिकॉज दे डोंट बॉन्ड इन द फर्स्ट प्लेस. ठीक है, सो रिमेंबर दैट. तो यू कांट यूज दिस टेक्निक के एक न्यूक्लियर और दूसरे न्यूक्लियर के बीच में डिस्टेंस मेजर करके यू डिवाइड बाय 2 सो यू गेट द एटॉमिक रेडियस. सो दैट्स, तो इसलिए ना ये जो डेटा बुकलेट है उसके अंदर दिस इज इनकरेक्टली कैलकुलेटेड. द अदर थिंग इज वो है आइसो इलेक्ट्रॉनिक atoms or ions. Isoelectronic simply means same number. I said it means same number of electrons. So many atoms have same number of electrons. For example, you have neon, 10 protons, 10 electrons. ठीक है, you have Na plus 1, 11 protons, लेकिन it also has 10 electrons. And you have fluorine, which is minus 1, it has 9 protons. ठीक है, लेकिन all of them, they have 10 electrons. Neon के पास तो वैसे ही 10 electrons, it's a neutral atom. Sodium had 11 electrons, but now it's plus 1, so that means it has a total of 10 electrons. Or fluorine was minus 1, but now it's going to, it's 9 electrons, but now it's minus 1, so it also has 10 electrons. So they all have exactly the same number of orbitals, subshells, the same shells. So the electronic configuration is identical. So which one is going to be the smallest? So remember, जिसके more protons होंगे ना, that's going to be the smallest. क्योंकि जितने ज़्यादा protons होंगे, the electrons are going to be very strongly attracted to the atom. तो वो 10 electrons को बड़ा strongly अपने साथ attract करेगा, so it's going to have a smaller radius. And जिसके least protons होंगे ना, वो सबसे कम attract कर रहा होगा. That is going to be the largest. ठीक है, so is this clear?
Yes.
तो ये थोड़ा सा ना आइसोइलेक्ट्रॉनिक एटम्स मतलब फिगर आउट के वो आइसोइलेक्ट्रॉनिक है कि नहीं है. ठीक है, they have the same number of electrons and you're being asked about the size of the atom or the ion, so just remember the one that has the most number of protons, it's going to attract the electrons very strongly, so it's going to be the smallest. And the one that has the least number of protons, electrons उसके पास भी उतने ही हैं, but it's not going to attract its electrons very strongly, so it's going to be the largest or biggest in. ठीक है, Minahil, is this clear? Rida, Hiba, is this clear?
Yes.
चलिए ठीक है, ये इधर से फिर हम कल कंटिन्यू करते हैं. ठीक है, ये बस छोटा सा था, इसके अंदर और कुछ भी नहीं है. एक दो पास पेपर क्वेश्चंस करेंगे इसके, फिर विल मूव टू केमिकल बॉन्डिंग. ठीक है, ओके देन, टेक केयर, अल्लाह हाफिज.